Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving Pascal's triangle. This is an easy problem and uh, this is just asking for printing the whole Pascal's triangle. Okay, so there are many approach to print Pascal's triangle. The first approach is for that the description problem description says we just do it what the question asks, that in Pascal's triangle each number is the sum of the two numbers directly above it. So where we are standing, let's say we are standing here, so we will just check what are the two elements above it and we will just sum it. 2 plus 1, that is 3. Okay, and yes, we will check for the boundaries also. If we are here, we will not check here, we will not go out of bound, so we will keep in mind that okay. So this was the approach one, that just do whatever the problem is asking, keeping in mind the boundaries, the edge cases. Okay, the approach 2 is a very famous approach, that any element in the Pascal's triangle is just NCR, where n is the uh, row minus 1, n is row minus 1 and r is column minus 1. And yes, we consider it as one based indexing. Suppose we have to calculate this number. Okay, so for if it is one based indexing, then we can say it is the row number is 3, and the column number is 2. So we will just calculate row minus 1, that is 2, and column minus 1, that is 1. So we will just calculate 2c1, so this will come 2. So the second approach is just calculate NCR, where n is row minus 1 and this is column minus 1. So we have to print the Pascal's triangle, so we will just iterate to each and every row and column and calculate and call out the function for NCR, where n will be row minus 1 and r will be column minus 1. But you know, for calculating NCR with the very optimized technique, it will take at most in the worst case it will take O of n time complexity, and for traveling each and every element, each and every row and column, this will be O of n square, and for calculating NCR this is also at most n, so this will be cubic time complexity. However, we know that the constraints are very low, but we will understand all the approaches, we will try all the approaches. So now in the third approach, what we will do, we will just call a function to generate the ith row. Okay, and we will do this for all the rows. Okay, so for generating the ith row, suppose we have to generate the last row. Okay, what is the last row? This is 1 4 6 4 and 1. So we know that the first element is always 1. So if we call the ith row generator function, so we will just first of all we will say the first element is always 1. Okay, now here is the logic. Suppose this row is 1 based. Okay, we will consider row as 1 based indexing. Now this is fifth row, and if we consider the columns as 0 based indexing, then now we have to generate the second element of that fifth row. So what we will do, we can see this is nothing but row minus the column number in the numerator divided by the column number, and the whole multiplied by the previous result, that is 1. So this is the logic, this is the formula, and we can see with the dry run that the first element is always 1, so we will just push back 1 in the starting. Now in the second one, that is 5 minus that is row minus column upon column into the previous result. Previous result is 1, so we will store result is equals to 1. Now the second one will be row minus column. Row is 5 and column is 1. Okay, so 5 minus 1 is 4. Wait, 5 minus 1 upon the column is 1 into the previous result. Previous result is 1, so this is simply 4. Next, row minus 1, that is 5 minus 2. Row is 5 and column is 2 upon the column. Column is 2 into the previous result. Previous result is now 4. Okay, so this will be 3 by 2 upon 4. This will be 6. This will be 6. 3 into 2, 6. So similarly we will see that here the any element is just the row minus column upon column into the previous result. So this is the simple, you can say, formula or logic we can see from the dry run also, because this will boil down our complexity to big O of n square. Okay, because we will go in each row, we will call the function for generating the ith row, and in for generating the ith row it will just calculate in one iteration. So we can say the maximum time complexity will be big O of n square. This is far more better than complexity that we were calling the NCR function, because it was taking extra big O of n time complexity. So this that was going big O of n cube. So I will be coding the last approach, that is the formula. So what we will say, suppose first of all we have to return the result, so we will just create a resultant vector and name it as result. Now what I was saying, that for each row rows, and I will call generate the ith row. So ith row, let's say name it as ith row, and we will call the function generate ith row, and there we will pass the row number. So the row number is I, and now after the row will be generated, we will say that just push back the result into our final vector. Okay, so ith row will be pushed into the result vector. Okay, and at the end we will just return the result. Now I have to write the function for generating the ith row. So what it was doing, it was just returning the ith row, int, just it was passing the row number. Now what's the logic? The first will be, okay, let's store this inside the result, what we have to return, and let's push back the very first element, that is 1. So we will push back 1 first. Now we will say the first element is 1, that is 1, so res is 1. Okay, now we have to go from next to the last, okay, the second to the last. So we will call the column, 0 based indexing is there, so column 1 to column, okay, so there are in each row, we can say there are row number of columns. In the first row there is 1 column, in the second row there is 2 columns, so we can say in each row there will be just row number of columns. Now we what was our logic? We will multiply the result with row minus column. This will be our numerator, and we will divide every time it by column. So after this will be calculated, we will just after this two things, numerator and denominator, this formula will calculate as the element, okay, at that particular row and column. Now after it is generated, we will just push back into our resultant vector, and after the ith row is generated, we will just return it, nothing else. So let's check whether we are able to pass all the test cases or not. Okay, we are able to pass all the test cases, the sample test cases. Let's submit it, and we have solved the problem successfully. And if I talk about the time complexity, we can see the generate ith row function is maximum going row times, so there is just big O of n time complexity here, and this function is also going total number of rows times. So we can say that this for loop is taking big O of n, and the inside generate ith row is taking big O of n. So we can say that the time complexity is big O of n square. Okay, and if we talk about the space complexity, so see, space complexity is big O of n square just for storing the resultant vector, okay, okay, but we can see we have to return it. In the question it is asked to, we have to create the resultant vector, but if we talk about the extra space, we haven't taken any extra space. So we can also say that the space complexity is big O of 1, but yes, according to the rules, we can just say after seeing it, this function which I have written, we can see that yes, space complexity big O of n square, but we haven't taken any extra space. Okay, so we can see that time complexity is big O of n square. This is far more better than that NCR function which we have to call again and again. So this is better. So from this question we have understood three approaches, and we have also known that if a question comes that asks for just calculating the, if it gives row and column, we have to just tell what's the element in that row and column. We will just call the NCR function. Second, we have understood how to calculate the ith row, and third, we have understood how to generate the entire Pascal triangle. Okay, so that's all for this problem. Thanks for watching. Until then, keep learning and keep upgrading yourself every day. See you in the next video.